Imagine this for a second, our beautiful planet Earth, spinning silently in the vastness of space, is approximately 4.5 billion years old. That's an incredibly long stretch of time. So long, in fact, that it's hard for the human mind to even comprehend it properly. Now, within this unimaginable expanse of time, humans, the species we know today, have existed for only a tiny fraction. The earliest ancestors of humans, known as hominins, emerged around 7 million years ago. And when it comes to modern humans, the species Homo sapiens, we've only been around for about 300,000 years. Think about that for a moment. Out of 4.5 billion years, we've only just arrived, like showing up at the very last second of a movie that's been playing for hours. Now here's the question that starts to get really interesting. What about all those billions of years before us? What was happening on Earth long before humans even existed? Was the planet simply empty, quiet, untouched, covered only in plants, dinosaurs, and natural landscapes waiting for humans to appear? Most people would automatically say yes. That's been the commonly accepted story for generations. But in recent years, a fascinating and provocative idea has emerged that challenges everything we thought we knew about Earth's history. It's called the Silurian Hypothesis. And it asks a question so bold, so unexpected, that it's making scientists and thinkers around the world stop and reconsider our place in the history of this planet. This idea didn't just come out of nowhere. In 2018, two respected scientists, astrophysicist Adam Frank from the University of Rochester and climate scientist Gavin A. Schmidt from NASA's Goddard Institute for Space Studies, joined forces to publish a groundbreaking research paper. Their goal: to ask, if an advanced civilization existed on Earth millions of years before humans, would there be any way for us to detect its presence today? Their paper, titled The Silurian Hypothesis: Would it be possible to detect an industrial civilization in the geological record, is both a thought experiment and a scientific investigation. It raises astonishing questions about what kinds of traces an ancient civilization might leave behind, and more disturbingly, how those traces could be completely erased over time by the natural processes of our planet. Let's really think about that for a moment. Suppose, just suppose, that long before humans ever walked the Earth, there was another intelligent species here. Maybe they built cities. Maybe they developed technology. Perhaps they even dominated the planet for tens or hundreds of thousands of years. But over the course of millions of years, could all of their creations, their buildings, their artifacts, their history, simply vanish without a trace? As it turns out, the answer might be yes. Our own civilization, as mighty and advanced as we think it is, would be shockingly fragile on a geological timescale. If humans were to suddenly disappear from the Earth today, scientists estimate that within just a few thousand years, most of our visible structures would crumble away. Our skyscrapers would collapse, our bridges would rot, plastics would degrade, especially under constant exposure to sunlight and bacteria. Even the most resistant materials like metal and concrete would erode, break down, or sink beneath layers of sediment. Radioactive waste might last a bit longer. Plastics might survive in some form for a few million years under specific conditions, but given enough time, millions or even tens of millions of years, nearly every trace of us could be wiped clean from the planet's surface. And if that's the case for us, then it opens up a stunning possibility. What if there were civilizations before ours, and nature has already erased them completely? This leads us to the term Silurian itself. Where does it come from? Interestingly, it's a reference to a period in Earth's distant past, the Silurian period, which lasted from about 443 million to 419 million years ago. It was part of the Paleozoic era, and although life during this time was mostly concentrated in the oceans, the period marked significant evolutionary developments, such as the first appearance of coral reefs and jawed fish. But the term Silurian hypothesis wasn't just randomly chosen. It was inspired by a classic science fiction story from the British TV series Doctor Who, where a species called the Silurians, intelligent reptiles, were said to have ruled the Earth long before humans ever evolved. Of course, Frank and Schmidt weren't claiming that lizard people once roamed the Earth. Their point was more scientific and more chilling. If Earth has been home to intelligent life more than once, could we even recognize the signs after so much time has passed? This is just the beginning of the mystery, a question that forces us to challenge everything we thought we knew about Earth's history. Could humans simply be the latest chapter in a very ancient, ongoing story of life and civilization on this planet? Stay with us, because what comes next might just change the way you look at human history forever. Now, here's where things get even more intriguing. When astrophysicist Adam Frank and climate scientist Gavin Schmidt introduced the world to the Silurian Hypothesis, they weren't just tossing around wild science fiction ideas for entertainment. In fact, they were deadly serious about a question that seems almost impossible at first glance. If an intelligent civilization had existed on Earth millions of years before humans, could we actually find any evidence of them today? The short and rather sobering answer they came up with: probably not. That's right. According to their research, the chances of uncovering solid physical proof of an ancient pre-human civilization are shockingly slim. But before we explore why that's the case, let's quickly address the playful nod these scientists made. A tip of the hat to pop culture fans everywhere. If the name Silurian sounds familiar, it might be because of the famous British sci-fi series Doctor Who. In this long-running show, there's a fictional species called the Silurians, an intelligent reptilian race that supposedly ruled the Earth long before humans ever came onto the scene. These Silurians were depicted as technologically advanced beings who later went into hibernation, only to awaken millions of years later to find humans ruling their planet. While Frank and Schmidt weren't literally suggesting that lizard people once roamed prehistoric Earth, they appreciated the metaphor. After all, their hypothesis wasn't about any specific species from TV shows. It was about the bigger idea. Could intelligence have evolved on Earth long before humans and left almost no trace of its existence? And so, blending their thought experiment with a playful wink at Doctor Who, the Silurian Hypothesis was born. But this idea wasn't just about storytelling. Frank and Schmidt's work was rooted in real science, exploring serious questions about geology, climate science, and the nature of evidence itself. Why wouldn't we find obvious physical proof? Here's the core problem, and it's a fascinating one. Earth is not a static, frozen world where things stay the same forever. Far from it. Our planet is alive in the geological sense. It is constantly shifting, breaking apart, rebuilding, and reshaping itself. Even the mightiest human-made structures today, skyscrapers, dams, bridges, entire cities, are no match for the titanic forces of nature when given enough time. Frank and Schmidt pointed out several key processes that would likely erase most physical traces of an ancient industrial civilization over millions of years. Earth's outer shell is divided into massive slabs of rock called tectonic plates. These plates are always moving, colliding, and diving beneath one another. Over tens of millions of years, entire continents can be broken apart or mashed together, sending anything on the surface deep into the Earth's mantle where it's destroyed. Wind, rain, rivers, and ice slowly, but relentlessly, wear down everything on the surface of the planet. Even the pyramids of Egypt, built just 4,500 years ago, show signs of significant weathering. Now imagine millions of years of erosion at work. The process of fossilization is rare and highly selective. It generally requires very specific conditions: quick burial, low oxygen, and mineral-rich waters. Most organisms, objects, or structures are never fossilized. Organic materials and many manufactured materials simply decay and vanish. Volcanoes can bury entire regions under molten lava or volcanic ash, obliterating evidence of civilizations beneath layers of rock. Put simply, Earth has an astonishing ability to wipe its surface clean over long periods of time. So, what could possibly survive? Since skyscrapers, roads, and even metal artifacts are unlikely to survive millions of years of geological processes, Frankenschmidt proposed a different approach, one that was far more subtle and scientific. Rather than looking for ancient ruins or fossilized smartphones, they suggested we should search for chemical fingerprints, anomalies or unusual patterns in the geological record that might hint at past industrial activity, changes in carbon isotopes in ancient sediments, unnatural concentrations of certain metals or plastics, strange chemical residues that can't easily be explained by natural processes. This is the kind of evidence that could potentially survive Earth's constant transformations. After all, even today, our industrial civilization is leaving behind chemical markers, pollution, plastics, radioactive elements that might be detectable millions of years into the future by whatever species comes after us. One of the most fascinating things about our planet is how dynamic and restless it truly is. The Earth is like an artist constantly painting over her canvas, erasing the old to make room for the new. Consider this. The floor of today's oceans could one day be thrust up into mountain ranges. The Himalayas themselves were once at the bottom of an ancient sea, and the sprawling deserts of today might someday be fertile plains or bustling coastlines. Geological processes like erosion, plate tectonics, volcanism, and fossilization are constantly rewriting Earth's story layer by layer, piece by piece. This is both humbling and mysterious, because it means much of Earth's ancient past may forever remain hidden beneath its surface or lost to time. But does that mean we should stop looking? Not at all. In fact, it's these very challenges that make the search for ancient civilizations before humans even more thrilling. It forces scientists to think creatively, to search beyond bones and stones, and to look for the hidden clues left in the chemistry of the Earth itself. Because who knows? Perhaps buried deep within the planet's crust are the silent fingerprints of a civilization that thrived long before we ever dreamed of walking upright. Let's zoom in on one of the most underestimated but powerful forces that shape our planet plate tectonics. Now, when most of us think of the ground beneath our feet, we picture something solid, stable, unmoving. After all, unless there's an earthquake, the Earth feels pretty reliable, right? But beneath that quiet surface, the reality is far more dramatic. Earth's outer shell, called the lithosphere, isn't just one big, unbroken slab of rock. It's actually cracked into giant puzzle pieces called tectonic plates, and these plates are constantly moving, not fast enough for you to feel it as you stand there sipping coffee, but fast enough that over millions of years, entire continents have shifted, mountains have risen and fallen, and ocean floors have disappeared into the belly of the Earth. It's the ultimate slow-motion demolition and recycling process. And here's where things get really wild. Where these tectonic plates collide, one plate often slides beneath the other in a process scientists call subduction. Think of it like an enormous conveyor belt. The top layer of the Earth gets sucked downward, deep into the mantle, where it melts, transforms, and is eventually reborn as new rock elsewhere. This means that the surface you're standing on today could, given enough time, be swallowed back into the planet. And with it, everything built on it, cities, monuments, highways, even entire civilizations erased and recycled. Sound unbelievable? Well, let's look at some numbers. Did you know the oldest part of the ocean floor that we've ever discovered is only about 200 million years old? That might sound ancient, but in geological terms, it's actually quite young, especially when you remember that Earth itself is roughly 4.5 billion years old. So what happened to all that older oceanic crust? Gone, recycled, pulverized beneath the surface and replaced with new crust over and over again. Even the continents, which move more slowly, are subject to the same fate over longer timescales. And while land can sometimes preserve ancient rock better than the ocean floor, it still faces other relentless enemies: erosion and weathering. Let's step away from plate tectonics for a moment and talk about erosion. Even right now, as you read this, forces like wind, rain, rivers, and ice are quietly scraping away at the world around us. Mountains, towering symbols of permanence, are actually being worn down, grain by grain, into dust and sediment. Water carves through rock like a sculptor with endless time. Wind sweeps away loose particles. Rivers dig deeper channels. Glaciers grind valleys into shape. And over millions of years, entire landscapes are reshaped beyond recognition. But what about human artifacts? Surely materials like concrete or metal could last, right? Well, not really. Concrete breaks down under chemical attack and weathering. Metals corrode, rust, and eventually disintegrate, especially when exposed to water, oxygen, and microbes. Given a few thousand years, even our most durable structures crumble. Give nature 1,000,000 years or more, and everything we've built turns to dust. As for fossilization, the process we often associate with preserving ancient life, it's incredibly rare and selective. Most materials decay long before they ever have a chance to fossilize. Even if something does fossilize, it's usually biological material, like bones or shells, not skyscrapers or machines. Here's the shocking truth. In the vast library of rocks that make up Earth's crust, only a tiny fragment of the planet's full history has been preserved. Think about it. Earth is 4.5 billion years old. Yet the preserved geological record is like trying to understand the entire Harry Potter series from reading a few torn-out pages scattered randomly on the ground. Entire chapters, maybe entire volumes, could be missing forever. Which brings us back to the bold thought experiment of Adam Frank and Gavin Schmidt. If an advanced civilization, perhaps as technologically capable as ours, or even more so, had existed millions or even hundreds of millions of years ago, would we find their cities, their machines, their footprints? Not because they never existed, but because Earth itself would have obliterated almost every physical trace of them through tectonic recycling, erosion, and time. So, how can we possibly know? This is where Frank and Schmidt took their hypothesis in a different, fascinating direction. Since physical evidence would likely be erased, they argued that the search for ancient civilizations should shift towards something else, something far harder to destroy. They proposed looking for odd chemical signatures in ancient rocks and sediments, patterns in carbon isotopes that don't fit natural cycles, traces of synthetic materials or metals in unusual concentrations, signals of large-scale industrial activity that might show up in the atmosphere or ocean chemistry even after millions of years. It's a brilliant idea because while mountains crumble and oceans swallow land, certain chemical fingerprints might just outlast everything else. In other words, if the ruins of a forgotten civilization are gone, perhaps their pollution isn't. When faced with the absence of what you want to find, you search for what you can find. And that's the principle Frank and Schmidt built their entire Silurian hypothesis around. They knew that the Earth is an expert at covering its tracks. But they also knew one thing. No matter how clever nature is, sometimes it leaves behind just enough clues for a curious species to wonder. Were we really the first? By now, you might be thinking, all right, if an ancient advanced civilization like the hypothetical Silurians really did walk the Earth millions of years ago, and if all their buildings, machines, and highways have long since crumbled into nothingness, is there anything left that could prove they were here? This is exactly where Adam Frank and Gavin Schmidt steered their investigation next. See, while the forces of erosion, plate tectonics, and time are merciless to physical structures, there's one type of evidence that's much, much harder to erase: chemical fingerprints. And that's where the Silurian hypothesis gets seriously intriguing. Imagine this. You walk into an empty room. There's no furniture, no footprints, nothing visible to suggest that anyone's been here before you. But then you whip out a blacklight and suddenly, stains and smudges you couldn't see with the naked eye begin to glow. Evidence of past activity, hidden in plain sight. That's essentially what Frank and Schmidt proposed, but on a planetary scale. Instead of expecting to find ancient tools or fossils of skyscrapers, they suggested that we might find subtle chemical clues left behind in the Earth's geological record. Clues that could survive long after physical evidence has turned to dust. One of the most compelling pieces of potential evidence comes from, believe it or not, carbon isotopes. All life on Earth is made of carbon, but not all carbon atoms are created equal. The two most stable types are carbon-12, the lightweight version, and carbon-13, a little heavier. Normally, nature maintains a pretty consistent balance between the two. But industrialized civilizations, especially those that burn massive amounts of fossil fuels, mess with that balance. Fossil fuels like coal, oil, and natural gas are packed with carbon-12 because they're made from ancient organic matter. So when you burn them at industrial scales, you flood the atmosphere and eventually the geological record with extra carbon-12. Fast forward millions of years, and if geologists detect an unusual spike in the carbon-12 to carbon-13 ratio in specific sediment layers, well, it might just raise a few eyebrows. It would essentially whisper from deep time, someone was burning a whole lot of carbon-based fuel here way before modern humans showed up. But let's suppose this ancient civilization didn't just burn fossil fuels, let's say they farmed too. Modern agriculture relies heavily on nitrogen-based fertilizers, and their widespread use leaves a chemical signature behind, specifically abnormal ratios of nitrogen-15 in soils and sediments. If the Silurians, or any ancient industrial civilization, practiced large-scale farming with synthetic fertilizers, we might be able to detect those anomalies millions of years later. It's like finding the forgotten footprint of a lost farming empire etched into the chemistry of the Earth itself. But Frank and Schmidt didn't stop there. In true sci-fi fashion, and perhaps with a little nod to every doomsday movie ever, they asked, what if this ancient civilization discovered nuclear technology? Sounds crazy? Maybe. But let's play along. If a pre-human industrial society developed nuclear energy or worse, engaged in nuclear warfare, they would have unleashed radioactive isotopes that don't naturally occur in significant amounts on Earth. Isotopes like plutonium-244 or iodine-129 are essentially calling cards of nuclear reactions. And here's the kicker. These isotopes have incredibly long half-lives stretching from millions to hundreds of millions of years. Translation: if these isotopes were produced in large enough quantities by ancient nuclear activity, tiny traces of them could still be detectable in ancient rock layers today. It's like finding invisible ink scrawled across the pages of Earth's geological diary. But wait, there's one final piece of the puzzle. Frank and Schmidt also pointed out that any industrial civilization with a love affair for fossil fuels, sound familiar, would have likely altered their planet's atmosphere in a measurable way. Burning fossil fuels doesn't just mess with isotope ratios, it also pumps a ton of carbon dioxide, CO2, into the air. If an ancient civilization triggered a massive climate shift through CO2 emissions, like global warming or mass extinctions, it might leave behind clear signs in the sediment record, changes in temperature, disruptions in ocean chemistry, and sharp rises in carbon concentrations. In essence, a geological scar of their existence. So, what would we actually look for? Frank and Schmidt weren't just playing a game of what if. Their paper laid out serious scientific approaches to hunting for these chemical clues, including abnormal carbon isotope ratios, nitrogen isotope anomalies from fertilizer use, traces of long-lived radioactive isotopes, sudden temperature spikes or climate disruptions. layers of unusual metals or synthetic compounds, patterns of extinction events without clear natural causes. The Silurian hypothesis doesn't claim there was an ancient industrial civilization, but it does something even more thrilling. It asks us to look at our planet in a completely new way, not just as a passive rock orbiting the sun, but as an active storyteller, a place that might hold forgotten secrets in its very bones. The real question is, are we clever enough to read them? But let's not get carried away just yet. Because just when you thought the Silurian hypothesis was about to hand us the ultimate cosmic plot twist, lizard civilizations causing ancient global warming and fighting radioactive wars, science throws us a curveball. You see, Adam Frank and Gavin Schmidt were very careful about something. Just because we find certain chemical signatures doesn't automatically mean an ancient industrial civilization was responsible. In fact, nature itself can be a very convincing copycat. Remember those weird chemical fingerprints we talked about? The unusual ratios of carbon or nitrogen? The traces of radiation? The sharp spikes in atmospheric carbon dioxide? Yeah. Mother Nature has been pulling off that exact same trick for billions of years no ancient lizard empire required. Take global warming, for example. Sure, it's tempting to imagine that if we found evidence of ancient climate change buried in rock layers, it could be a leftover scar from some prehistoric industrial revolution. But here's the thing. Earth itself has triggered global warming events long before humans, or possibly even Silurians, came along. One of the most terrifying examples of this? The Permian-Triassic extinction event, often called the Great Dying. This happened around 252 million years ago and was, without exaggeration, the worst mass extinction event in Earth's history. Scientists estimate that up to 96% of all marine species and 70% of terrestrial species vanished. The suspected culprit? A catastrophic episode of volcanic activity in what is now Siberia, known as the Siberian Traps. These volcanic eruptions released mind-bending amounts of carbon dioxide and methane into the atmosphere over thousands of years. This didn't just warm the planet, it superheated it. Oceans turned acidic, oxygen levels plummeted. Life nearly got wiped out entirely. And yes, this left chemical fingerprints eerily similar to what an industrial civilization might leave behind. Spiked CO2 levels, altered carbon isotope ratios, and layers of dead zones in sedimentary records. But there were no factories, no cars, no skyscrapers, just Earth doing what Earth sometimes does, go completely bananas. And what about nuclear evidence? Surely radiation points to technology, right? Well, not so fast. In one of the most astonishing natural discoveries of the 20th century, scientists found something in Africa that seems almost impossible, a natural nuclear reactor. Welcome to Oklo, in modern-day Gabon, West Africa. Roughly 2 billion years ago, the conditions in this region were just right for uranium deposits to undergo spontaneous nuclear fission, the same process used in modern nuclear power plants. For hundreds of thousands of years, Oklo functioned as a natural nuclear reactor, generating heat and altering local chemistry entirely without the help of any civilization. And yes, this event left behind radioactive isotopes, just like a human-made nuclear facility would. So once again, even if we find traces of ancient radiation, we have to ask ourselves, was this the work of intelligent life? Or just the universe being weird again? And it doesn't stop there. Even some of the other evidence proposed by the Silurian hypothesis has natural explanations. Nitrogen-15 anomalies, lightning strikes can cause those, sudden metal concentrations in soil, meteor impacts and volcanic eruptions can do that, changes in ocean chemistry, shifting tectonic plates and undersea volcanic vents play a role. Mother Nature is, without a doubt, the ultimate wildcard. And that's what makes the Silurian hypothesis so difficult and so brilliant. It's not just a quest to find strange data. It's a test of scientific reasoning. Frank and Schmidt weren't claiming there was an ancient industrial civilization. They were challenging us to figure out how we would even tell the difference between nature's chaos and the fingerprints of intelligence. How do you separate ancient volcanism from ancient factories? How do you distinguish natural nuclear reactions from the fallout of prehistoric wars? And if we can't tell the difference down here on Earth, how are we ever going to do it when looking for signs of life on other planets? As exciting as the idea of reptilian empires and ancient nuclear wars might sound sometimes, nature is already stranger, more destructive, and more creative than any sci-fi story we could dream up. But that doesn't mean we stop looking. Because if an ancient industrial civilization did exist somewhere in the far forgotten reaches of Earth's deep time, the clues might still be out there, hidden beneath our feet. But just when it seemed like every clue, every test, every chemical signature could be explained away by nature's weirdness, Frank and Schmidt reached deep into their deck of theories and pulled out their boldest card yet, their ace, their ancient wild card. Sounds fancy, right? Well, it should, because to this day, the PETM stands as one of the most bizarre and extreme climate events ever recorded in Earth's deep history. And here's why it got everyone's attention. We're talking about a time roughly 56 million years ago, long, long before humans, before mammoths, even before the first apes showed up. Suddenly, and geologically speaking, suddenly could mean over a few thousand years the Earth went into climate overdrive. Temperatures skyrocketed by 5 to 8 degrees Celsius globally. Imagine the kind of heat wave that could turn the North Pole into a tropical resort. Because that's basically what happened. Some estimates suggest Arctic waters reached up to 20 degrees Celsius, practically beach weather. This global heat wave didn't last a few summers either. It stuck around for over 200,000 years. And the cause? A jaw-dropping surge of carbon released into the atmosphere, enough to completely disrupt climate systems, reshape ecosystems, and leave chemical fingerprints in the rock layers that can still be detected today. Because that is exactly what we fear happening in our modern Anthropocene era, the era shaped by human industrial activity. Hold on. Was this the work of the Silurians? Now, here's where things get spicy. Frank and Schmidt looked at the PETM and basically asked, if human industry is powerful enough to heat the planet today, what's stopping us from wondering whether an ancient civilization, say, the Silurians, could have done the same thing millions of years ago? If industrial civilizations inevitably burn fossil fuels, and burning fossil fuels inevitably dumps massive amounts of carbon into the atmosphere, and if those emissions leave behind chemical clues in rocks, then doesn't the PETM start to look a little suspicious? Could this have been the ancient climate crisis of a forgotten civilization? Did the Silurians drive their own version of cars, power plants, factories, only to doom themselves in a prehistoric climate catastrophe? It was the ultimate mic drop moment for the Silurian hypothesis, but just like every plot twist in science, it came with a reality check. As intriguing and cinematic as this idea was, the scientific community wasn't buying it. Following Frank and Schmidt's paper, other researchers pointed out that the PETM had plenty of natural explanations that didn't require ancient reptilian industries or fossil fuel addiction. For starters, massive volcanic activity during that period could have triggered the carbon release. Specifically, undersea volcanic activity along what's known as the North Atlantic igneous province could have cooked buried organic material, releasing greenhouse gases in the process. Other theories point to methane hydrates, icy deposits of methane trapped under the ocean floor, suddenly releasing into the atmosphere due to warming seas. Both scenarios can explain the massive carbon spike without any need for ancient smokestacks or lizard-shaped corporate logos. And let's not forget, the pattern of carbon release during the PETM was still far slower compared to modern-day human emissions. Today's industrial carbon release is happening 10 times faster than it did during the PETM. So if there was a Silurian industrial revolution, they were surprisingly patient polluters. Sadly, or maybe thankfully, the PETM, while dramatic, doesn't hold up as evidence of an ancient industrial civilization. It remains, to the best of our knowledge, Another chapter in Earth's long, strange history of extreme natural events. But what Frank and Schmidt did accomplish was something far bigger than just hunting ancient lizard cities. They made us ask better questions. They made scientists re-examine how civilization-scale activity, whether human or alien, might leave traces detectable across millions of years. They forced us to wonder, if Earth could hide the rise and fall of an industrial species once, could it do it again? And perhaps most importantly, if we did vanish tomorrow, what would our fossils say about us 56 million years from now? Would we become another PETM, or just another mystery buried beneath the dust of time? The Silurian Hypothesis might have lost its ace card with the PETM, but the mystery didn't end there. Sure, the PETM carbon spike could be explained by natural forces, giant volcanoes, methane bursts, or carbon-rich sediments roasting beneath ancient lava flows. And yes, no fossils, no artifacts, no ruins from a forgotten industrial society ever turned up in rocks from 56 million years ago. Plus, let's not forget, if there had been a hyper-industrial civilization burning through fossil fuels like humans today, the carbon release would have been rapid, sharp, and aggressive. Instead, the PETM was slow, gradual, exactly like the fingerprint left by Mother Nature, not a bustling civilization of ancient engineers. So with that, Frank and Schmidt's last card hit the table, and the Silurian Hypothesis seemed to fold. Because there's another card hidden in Earth's prehistoric deck, one that's been staring us in the face all along. Wait. Were dinosaurs smarter than we thought? For the longest time, dinosaurs have gotten a pretty bad rap. Big? Definitely. Terrifying? Absolutely. But intelligent? Not so much. Most paleontologists saw them as oversized reptiles ruled purely by instinct, the ancient equivalent of muscle over mind. Take the Stegosaurus, for example. This beast was the size of a small bus. But its brain? No bigger than a walnut. Scientists used to joke that the Stegosaurus had a second brain in its hips just to control its body, which was later debunked. So naturally, the idea of dinosaurs building cities, developing technology, or forming civilizations was thrown out the window. But science evolves, and so does our view of dinosaurs. While many dinosaurs weren't exactly genius material, one particular group has long intrigued scientists. Troodontids were small, bird-like dinosaurs, agile, sharp-eyed, and most importantly, they had the highest brain-to-body ratio of any dinosaur we know of. In other words, if dinosaurs had an honor roll, troodontids were definitely on it. Some paleontologists even speculate that, had the asteroid impact 66 million years ago never happened, troodontids could have evolved into something truly extraordinary, possibly even intelligent, sentient beings. This isn't just science fiction either. In 1982, paleontologist Dale Russell proposed the famous Dinosaur hypothesis, a thought experiment imagining what an intelligent, tool-using dinosaur might have looked like today. Picture a bipedal reptile with large eyes, grasping hands, and an expanded brain case. It eerily resembles classic depictions of aliens in popular culture. Could dinosaurs have built civilizations? This brings us to a deliciously strange question. If evolution had given them enough time, could dinosaurs like troodontids have developed language, technology, even cities? Some scientists argue it's unlikely, pointing out that intelligence on a human level is extremely rare in the history of life. Others say it's not impossible intelligence evolves under the right pressures and opportunities. Even if an advanced dinosaur civilization had existed millions of years before humans, would we even know? Remember, Earth is a master recycler. Over tens of millions of years, continents shift, mountains rise and fall, oceans swallow cities, and rocks get pulverized, melted and reborn. If we vanished tomorrow, the skyscrapers of New York might not last 100,000 years, let alone 66 million. All that might remain are chemical fingerprints in the rocks, or fossils. But so far, no cell phones trapped in amber, no dinosaur microchips buried under ancient lava flows. But as you're about to see, even bones can tell a story far stranger than we once believed. But everything we thought we knew about dinosaurs began to shift in recent years. It started in 2021 when one scientist dared to look beyond the stereotype of dinosaurs as nothing more than prehistoric beasts. His name? Diego Pol. A respected paleontologist from Argentina, Pol decided to focus not on the famous predators like T-Rex or velociraptors, but on an unlikely candidate, the Maiasaura. These weren't fearsome hunters. They were peaceful, herbivorous creatures, duck-billed dinosaurs who roamed the late Cretaceous period, roughly 76 million years ago. And what Pol uncovered about them would shock the entire scientific community. The Maiasaura mystery, dinosaurs with a social system. Maiasaura literally means good mother lizard. The name comes from an extraordinary behavior discovered in their fossil record. They took care of their young. Unlike many reptiles today who lay their eggs and abandon them, the Maiasaura showed signs of returning again and again to the same nesting sites for generations. Year after year, herds of Maiasaura would migrate across vast prehistoric landscapes, only to return to the exact same spot to raise their young. That's not just instinct. That's memory. That's environmental assessment. That's long-term planning. Pol's research revealed something even more astonishing. These dinosaurs displayed cooperative behavior within their herds. The stronger adults protected nesting females and vulnerable eggs. Younger, more agile dinosaurs ventured further to forage for food. The entire community worked together, ensuring the survival of their next generation. This isn't just remarkable for dinosaurs, it mirrors behaviors we see in highly intelligent species today, like elephants, wolves, and even primates. And for the first time, scientists were forced to ask, were dinosaurs a lot smarter than we've been giving them credit for? As incredible as the Maiasaura were, they might not even be the closest contenders for intelligence in the dinosaur world. That title. It most likely belongs to a small, unassuming, bird-like predator, Troodon. At first glance, Troodon didn't look like much. It was roughly the size of a modern-day raptor, with sharp claws, a slender build, and a lightweight frame. But hidden inside that small skull was something extraordinary. Troodon had the largest brain-to-body ratio of any known dinosaur. In the prehistoric arms race of size and strength, Troodon was investing in something different: brain power. Binocular vision, depth perception for hunting, grasping, semi-flexible hands, perfect for manipulating objects, and complex hunting strategies, potentially working in packs. And you've got a recipe for an animal teetering on the edge of what scientists call incipient intelligence, the first spark of higher cognition. This is where things get wild. In 1982, paleontologist Dale Russell took this idea to its extreme conclusion. He proposed a thought experiment. What if the Troodon species hadn't gone extinct? What if, given millions of additional years, they kept evolving? Russell's answer was the Dinosauroid. Picture this: a humanoid dinosaur standing upright, with large forward-facing eyes, dexterous hands, and a highly developed brain. According to Russell, this hypothetical being could have developed tools, built cities, and maybe even launched itself into its own industrial age. Far-fetched? Sure. But impossible? Not necessarily. Evolution has no set direction, only possibilities. And if Troodon had the raw ingredients for intelligence, who's to say what could have happened if fate rolled the dice differently? But here's the eternal problem. Where's the proof? This brings us back to the core of the Silurian hypothesis. Could an intelligent dinosaur species have existed millions of years ago, and we simply missed all the signs? Sadly, despite the tantalizing clues, there's no direct evidence, no ancient dinosaur cities, no fossilized tools, no prehistoric writing. But the Silurian hypothesis doesn't give up so easily. If such a civilization did exist, their traces might not look like skyscrapers or golden artifacts. They might instead be hidden in the very rocks beneath our feet, subtle isotopic anomalies, chemical fingerprints, or unexplained shifts in the Earth's ancient layers. The idea of intelligence arising in unlikely forms doesn't stop with dinosaurs. Over 2 decades ago, in a quiet Japanese laboratory, biologist Toshiyuki Nakagaki conducted an experiment that would shake our understanding of life itself. Nakagaki placed a simple slime mold, an organism without a brain, nerves or muscles, at one end of a maze. At the other end, a cube of sugar. What happened next was nothing short of mind-blowing. The slime mold began to spread its tendrils, probing the maze. It tested paths, learned from dead ends, rerouted itself, and within hours, it successfully navigated the labyrinth to reach the sugar. A brainless organism solving a problem designed for creatures with intelligence. It made scientists wonder what else is out there, capable of thinking in ways we can barely comprehend. And this brings us to one of the most provocative questions of all. Could fungi, those humble, brainless organisms we see on forest floors and in damp corners, have once formed the foundation of an ancient intelligent system? But if there's one thing history teaches us, it's that nature rarely cares about human expectations. Fungi, the silent architects of intelligence. After all, slime molds like the one in Nakagaki's experiment have displayed learning behaviors that challenge our entire definition of intelligence. They solve mazes. They optimize networks like railway systems. They adapt to changes in their environment. And here's where things take an unsettling turn. Fungi, unlike animals or dinosaurs, don't leave behind fossilized bones or obvious ruins. Their vast empires, if they existed, could have stretched underground, invisible to the naked eye, spreading like living networks of information beneath ancient forests. Imagine a civilization not built of stone or metal, but of living tissue, a global biological intelligence communicating across miles through underground mycelium networks. And if that civilization ever fell, what traces would it leave behind? Perhaps only faint chemical whispers, long buried in the soil, waiting for a future species like us to stumble across them. Because if we dare to look even further, the mysteries only multiply. Consider one of humanity's greatest architectural achievements, the pyramids. Standing proud and immovable for thousands of years, these structures have fascinated archaeologists, historians, and dreamers alike. But what if we've been asking the wrong questions all along? What if the pyramids themselves aren't just testaments to human ingenuity, but lingering echoes of a forgotten past? The pyramid puzzle, coincidence or ancient blueprint? Take the Great Pyramid of Giza in Egypt. Now cross continents to Italy's Chichen Itza Pyramid. Then travel even further to Mexico, where the Great Pyramid of Cholula rises from the earth. 3 pyramids, 3 vastly different locations, 3 entirely separate cultures, stepped structures, precise alignments to celestial bodies, monumental scale far ahead of their time. Mainstream history tells us these were independent creations, products of human genius across different civilizations. But the Silurian hypothesis dares to ask, what if they weren't entirely independent? What if, buried deep in humanity's ancient memory, or even deeper in Earth's history itself, there once existed a civilization advanced enough to inspire these designs across distant lands? A civilization that predates recorded history, perhaps even predates humanity. Were these mysterious pyramid builders descendants of intelligent dinosaurs like Troodon? Or perhaps a civilization of fungi intelligence that rose and fell long before bones could fossilize? Maybe they were something else entirely, beings who mastered their environment, left subtle traces of their knowledge, then vanished beneath the relentless march of geological time. The ultimate question: are the clues still there? This is the heart of the Silurian hypothesis. It doesn't boldly claim that such civilizations definitely existed, but it reminds us of a humbling truth. If a civilization had risen millions of years ago, be it dinosaur, fungal, or something stranger, the planet's powerful natural forces could have wiped away nearly every trace of its existence. Erosion, tectonic shifts, volcanic activity, the endless recycling of Earth's crust. Yet maybe not everything is gone. Maybe, just maybe, faint chemical fingerprints still linger beneath our feet. Anomalies in ancient sediments, isotopic signatures we have yet to decode, patterns in stone structures we've labeled coincidence, and all of it quietly waiting for someone curious enough to look closer. Final thought: what if we're not the first? Could we be standing atop the ruins of a forgotten world? Could humanity be just the latest chapter in Earth's long, mysterious story, not the first intelligent civilization, but simply the latest? That's the real power of the Silurian hypothesis. It doesn't just challenge science, it challenges imagination. Because sometimes the strangest mysteries are not hiding out in space. They're right here on Earth, beneath our feet. If this journey blew your mind, don't forget to hit that like button and subscribe for more stories that challenge what we think we know about history, life, and the universe. And until next time, stay curious.